Does it work? Testing. Oh, perfect. Hi, I'm Arnold Noronha. I work at Facebook, specifically on the Android newsfeed team. And today I'm going to be talking about fast deterministic screenshot tests. So first let's ask why, what problem are we trying to solve here? How do you test views? So typically, historically, your seasoned developers would probably tell you that you want to move logic out of your views. And so you can now start testing your logic separately as unit tests. And they will not really give you an answer for the actual view. In Android land, you would probably write either a roboelectric test to assert state on the view. For instance, if some text is set or if something has been clicked. It's either roboelectric or you could use espresso. One thing that we really don't test is things like paddings or margins or colors. And why is it that we don't test these things? The two answers to these, two completely opposite answers. The typical answer people will tell you is that views don't change that much, and it's actually more the logic that changes. And that's a lie, because if you look at any product and developer and how they actually do code, they're going to be changing padding, rerun the app, make sure the padding looks fine. If it's not right, they modify it again, and then they keep iterating like this until the view looks exactly how they want it to. So my answer to this is actually that the views change much more frequently, and it becomes much more painful to keep asserting your state in a test, which is really the problem why people don't really test view rendering. Oh, that was what I just answered. Yeah, so to give you a better example of why it's important to test rendering, let's consider Android newsfeed. Now, Android newsfeed has a lot of different configurations of feed stories. So it's really hard to test for a developer to test all of these different configurations. You might say that, well, that each of these, whoever owns each of these different story types, they should be responsible for testing their own story. But it turns out, we at Facebook, we are really good at reusing code. And reusing view code has some additional complications, because if you have infrastructure code and you're reusing it, if people go modify the infrastructure code, your API still remains the same, so the code which uses it probably is not going to change. Whereas with views, you might change a button's color from blue to green, and every other view which uses this button directly or indirectly is going to change. And it might change in unexpected ways. So, I mean, reusing code is great, but it causes its own sets of troubles. And we want to be really good at catching these regressions that come from these issues. So in order to try and find a solution, let's be inspired from test-driven development. And what might test-driven development look like for rendering code? Well, I personally see two important things that we need here. One, we need a fast feedback loop in development. And the point here is that you, like in a TDD programming style, you're going to write a test, you're going to write your code, make sure the test passes. If the test does not pass, then you have this fast feedback loop where you keep going back and forth until your test passes and you know your code is right. We need a fast feedback loop even when you're modifying views. Like the example that I gave you earlier, a product developer is constantly changing padding on a view. Typically, this is you're going to be building this huge app, and once you open the app, you're going to start navigating to your view. And this entire process is so slow that sometimes when I actually do this, I forget what I'm actually trying to test by the time I actually reach the view. So this is the first thing that I want in a solution for this. And the second thing I want is that I want to be able to catch regressions in continuous integration. So if a view changes, I need to know that it's changed. And sometimes it's going to be changing in bad ways, and I need to know when it changes in a bad way. The problem with the second part is that determinism is hard. It's not that there are no ways to do screenshotting. In fact, Monkey Runner does do that. So Monkey Runner would actually have a test process which runs outside the application process. But once you do that, you don't have any control over external factors in your actual test code. Because now you cannot tell your app to, you cannot mock out the network interactions and things like that. So if you take screenshots from something like Monkey Runner, you have very little control over the determinism of the actual screenshot. So then you might say, well, let's take the screenshot from something like an instrumentation test, like an activity instrumentation test case. This is better. You can now mock out external factors, but your test is still running on a different thread from the UI thread. So now you still don't have proper control over things like animations or even callbacks tend to have an issue. Like you have a handler like you post something on the handler, and even that causes issues with determinism. So, I mean, I'm not saying it's impossible, but every time you go about trying to do a screenshot with a full activity, it's just going to be a lot of work to make sure it's fully deterministic. So our approach to solving this is basically that we are going to mimic measure, layout, and draw. We're going to mimic measure, layout, and draw. So if you don't know measure, layout, draw, it's basically Android's way of converting a view hierarchy into something you see on the screen. So if you have the view hierarchy, it first walks the hierarchy and measures every view. So at this point, all the views have a height and width, and then it calls a layout. So at this point, every view has a position in its parent view, and finally, Android calls draw, which makes every view draw onto a canvas. So in our approach, we are doing all of this on the test thread, as opposed to having the measure, layout, draw being called from the Android framework on the UI thread. And so what we end up with is something that's really fast. It does not need activities to start up. And it's also deterministic, because the code that you see in this test is exactly what's being run. You'd have no interactions with your UI thread that you need for getting this in something deterministic. And we're happy to announce that we're going to open source this. It's not a huge library or something. It's a very nice, simple library which allows you to generate deterministic screenshots. I was planning to open source it today, but apparently I have to go through some more reviews before that happens. So I should have this by next week, and I'll show you the links and resources at the end by the end of the talk. Before that, I want to show you examples. So like stock code. So Alice has been given a task to create a search bar. So the search bar has a place where you can type text, and here's a search button. And so she's going to create search bar.html layout. And this layout is pretty straightforward. It's an edit text and a button inside a linear layout. So right now, she has given a hint to the edit text and a text to the button. So now Alice wants to verify that this layout works as expected. Now, her alternatives are she can plug this into the company's app, but now she has to find an appropriate place to plug it in, build the app, navigate to where the view is, and that just takes lots of time. So instead, what she does is that she writes a screenshot test. Now, this is all there is to a screenshot test, and I'm going to break this down for you. First, she inflates a view. In this particular case, it's a layout. It could be a view class, maybe something like a view container, like a frame layout, or like a derived class from frame layout or something like that. But in this case, it's simple. It's just a layout file. So she inflates the view. And now we want to call measure and layout on that. So our library provides a nice helper class called view helpers. And this is basically going to, so in this example here, she's setting an exact width, which is 300 dp for the view. And she's not setting a height, which makes it basically wrap content. And at the end of this call, the view has been measured and laid out. And so she can call this nice API screenshot.snap. At the end of this call, nothing is asserted here at this point, so your test is not going to crash. But at the end of this call, the the screenshot generated is going to be stored on the device SD card. So at the end of, so how would Alice run this? So here's how she's going to run it. So let's assume that we are using a Gradle as a build system. So I believe, I don't use Gradle enough, but I believe the correct command is Gradle W connected Android test. So this runs an instrumentation test. So the test completes and nothing gets asserted. So that's great. But now she needs to see what the screenshot looks like. So our library provides this script, pulls screenshots, and it takes the package that the test was like. You have to define a package for the test APK. So you just pull screenshots on that package name, and we dump an HTML file with the rendering of the view. Now, I mean, this was really fast. She got feedback as to how this view is with very little effort as opposed to plugging it into a full-blown app. And it also has some small features, like you can see there's a dump view hierarchy, so there's like small debugging abilities without having to have a running app. But okay, I talked about fast feedback loops, so what you notice here is that this view is not as you would think Alice wants, because if you would expect a search bar to have the search button aligned to the right. And in this example, you're seeing that it's not. So it's a bug, and Alice needs to go back and fix it. So she goes back to the view, and the fix is actually pretty simple. At least this is the way I would do it. So she sets the layout weight is equal to 1, which makes the edit text take the rest of the view, whatever is left over space. And she now wants to verify that this is working as expected. So she runs the test again, and lo and behold, it works. So this iterative cycle is like much more faster than having to plug this into a real app. But it gets better. I mean, this is just one small thing, but what if you can test in multiple different configurations all at one go? Your typical view could, like, you build a view, but you don't know how this view is going to look like at different widths or different languages. So you can just write multiple tests in multiple different configurations, and you can run this test and get all the screenshots at one go. So in this example, the first one sets the language of the language to Chinese. So it generates so you can see how the view looks like in Chinese. The second one sets a really long text. So the first and the last are hints. That's why they're gray, and the center one is actual text. And so it sets a really long text to the edit text, and it generates that screenshot. And the last one is what you already saw. Okay, so now, so at one go, Alice gets to see how her view looks like in multiple different configurations. And one thing interesting about this specific screenshot is that when I was building these slides, I made this layout, and I expected an edit text to be single line by default. And I just wrote the test because I assumed it's a pretty standard edge case. And the screenshot tests were the one that told me that I was wrong, and it's actually multi-line. And so I decided to leave it in just to give you a demonstration of how screenshot tests can catch something for me really quickly. So in this case, I found out that, I've actually committed this code into the open source repository, and in that I've actually fixed it by putting single line is equal to 1 or single line is equal to true, I think. So this is an example of how you can do a kind of TDD flow with UI rendering. Let's talk about the other important part, which is how do you use these screenshots? Now, TDD, I have given enough incentive for a developer to write screenshot tests even without tracking regressions. But if you tell them that, okay, now that you make the screenshot test, it's going to be catching bugs for you forever in the future, I mean, it's a very strong incentive. So let's talk about how we could potentially use this to track regressions. The first model is really very simple. It's just the record and verify model where you just record. So the first time somebody creates the screenshots, they run the test in a record mode, which generates all the screenshots and store your screenshots in the repository. And now anytime somebody else runs the test or the continuous integration runs the test, it's just going to run it in verify mode, and if the images don't match, it throws an exception. So this is a very simple model. It works pretty well. It does not require much tooling, and in fact it's been used in the iOS teams at Facebook for a while. One thing I didn't mention is that iOS has had a similar screenshot test framework for a while, released by Facebook. But they've been using the record verify model, where you record the screenshots, and when the tests are run later on, they just verify it against the golden screenshot. But it turns out that's actually more work for the developer, especially on a large project. For instance, at Facebook, we have 3 to 4 screenshot changes a day, whereas we catch only about 1 regression a week, which means if we do the record verify, we make a developer run record the screenshots 3 to 4 times a day when it's completely not required, when this could be automated. So we really optimize the workflow for the intentional changes. Another problem issue could be even at Facebook, we have multiple different build targets. So if you change a core component, a core widget, you might have to go run the screenshot test in record mode for all the other different targets, which can be lots of work. So what we really do at Facebook is continuous integration and bisect. So the record and verify both happens automatically. We run the test early, and most of the time nothing happens with these. But if we detect that a screenshot has changed from the previous hour, then we just start a new job which starts to bisect and find who blames and blame it to a single commit author. And it also notifies subscribers, which is pretty cool in itself, because if you're subscribed to some component that you built and there's like this core widget which somebody else built and they're changing that, you get to be notified that your view is changing. So this is great. Bisect might have edge cases because at times you cannot really bisect to a single diff. Like you might have multiple changes, or the build might be broken in between. But for the most part, this works really well. And as I mentioned, I work for Android Newsfeed. And so I'm going to mention a few things specific to Android Newsfeed, which makes screenshot tests really powerful. So stories in Android Newsfeed can be serialized as a JSON. And so we can start dumping hundreds of JSONs into our repository, and we automatically get a very large coverage across multiple different story configurations without much effort. Whereas if you had to actually generate for each view, you have to have a developer who's specifically writing test code for that view. And in fact, the slide towards the beginning where I showed you so many different stories, all of those screenshots are actually generated by our framework, and I just pulled this from our database. So I'm going to show you a few examples of things that we actually do. So this is one of those screenshots, and this is an actual screenshot from our database. And notice that there is a progress spinner in the center right there. Despite there being a progress spinner, this screenshot is always deterministic on every run. And the reason this works is that this view is generated on the on the test thread, which means that there are no handler callbacks coming to that animation, and it's going to be deterministic. The other thing I would point out, and this is like a very small fact, is a small thing to notice is that none of these screenshots had images. And the reason is that these screenshots are intentionally designed to not hit the network, and we figured that it's actually it's much more easy to just dump JSONs than also dump the associated images with it. So this just made things easier, and this really catches most of the bugs that we care about. Now I'll show you a few examples of real regressions that we have caught. So this one happened in the last week. So we had one engineer who built this screenshot test for this view. He built this many months ago, and last week somebody changed a core component which broke his view. So yeah, so the way our script works is that we notified that person, and we started bisecting. We figured out who the blame diff was, and they reverted their change, or actually fixed the change. So this was really powerful. Like somebody changed a component which affected other people's components, and otherwise there would have been no way to automatically catch this, and it would eventually be caught the day before release by QA, and that's not nice. This other example is much more interesting. The reason it's interesting is that if you look at it the human eye is probably not going to notice the regression here. Everything looks fine. When I got subscribed on this task, I looked at it. I couldn't really tell anything. And I eventually zoomed in, and I zoomed in to the bottom left corner, and this is what I got. So it changed from a rounded border to a squared border. And this is something even QA would not have caught, but it actually affects the polish of our app, so we really care about these kind of things. If we had been doing things like fuzzy detection as opposed to deterministic pixel-to-pixel changes, this change is really, really small, so you might actually not catch this. So it's really crucial for us that we have been deterministic with this and do notify on every exact pixel-to-pixel changes. So this is actually all I have for the talk. So thank you. So the first link is going to be the link for the screenshot test. Unfortunately, it's not public yet, but I'm giving you the link. The second link is the Google Groups mailing list. You can join that, and I will send out a notification with both the slides and once the repository is up online. Do you have any questions for me? Yes, please.
How complex are the views that you're going to play? So the thing that you showed us, the newsfeed thing, that was, you can write a test that inflates the subtle regression that you showed us, that all that data can be inflated in the test.
Okay, so yeah, so the question is whether the views whether all the views are actually inflated, I guess. So the nice thing so these tests are all instrumentation tests. So you can basically do anything that you can do in a real app, right? So the earlier examples I showed were basic layouts, but we can also use the entire app as an integration stack and mock out certain network interactions. So those newsfeed stories that you saw were almost integration code. So we take an actual list view, use the full newsfeed code onto that. The only thing we mock out is things like network interactions, broadcast receivers, things like that which cause flakiness. Yeah. Yes, please. So the question is whether we have thresholds for comparing screenshots. And this was a very intentional decision on our part to make sure that all the comparisons are deterministic. The reason is basically the kind of screenshots, the last screenshot I showed you, which is that usually many real interesting regressions that we have caught are these kind of things where it cannot be caught by the human eye. So whatever threshold that you put tends to be really even if you put a really small threshold, you're going to miss real regressions. Another interesting regression we had was where the thumbnail image became pixelated. So it was extremely small difference, but the image did become pixelated. So that was kind of cool. Yeah, so it's always deterministic. Yes?
When you deliberately change the UI, you have a good process to say, oh, this new screenshot is the new master.
Yeah. So the question is, how do we make sure? How do we set some screenshot as a new master if something changes intentionally? So yeah. So at Facebook, we generate. So if you change a screenshot, by default we assume that's the new golden screenshot. So you don't have to do anything for that, but we will send you a notification saying that look, the screenshot that you have been subscribed to has now been changed. At this point, the author can go back to the notification and say, oh, well, this change is not what I intended. So then they can go back and revert it. But by default, we have made the flow for intentional changes much more lightweight. Sure. Sure. Yeah. So the question is whether the views can also capture changes from Java code as opposed to just layout. And yes, the answer is the newsfeed examples that I showed you are actually using the whole Android newsfeed Java stack. So yeah, so the reason I showed the layout was just that it was much more simpler. But in that example, you inflated the view, but you could also have created that view just from a class or something like that. So it can use the full Java code. Yeah. Yes.
What the whole like bicep thing with the screenshot chain and signing tasks? How do you envision that to scale when you open source it? Because many people do that in workflows.
I didn't make this clear. Yeah. So So the way. So for the first part that we are open sourcing the library that deterministically generates screenshots. We think that's incredibly valuable, even in the record verify mode. And so that's what we are going to open source for the first part. Eventually, my plan is to have a script which actually, which might talk to MySQL to store the previous screenshots. But we're not going to open source that as a first part. But we will eventually do that. We definitely want to do that. Yes. That's actually a big feature request within Facebook. The answer is, I mean, it's tricky. I'm like, if somebody tells me we have been very careful about being deterministic in checking regressions. And if you want to do animations, you probably need to do some kind of, mock out the interpolator somehow. I'm sure it's doable, but we haven't done that. Happy to accept pull requests. Yes.
This actually detect color change. How you compare? Like, does it include colors?
Yes, it does. So yeah, the question is whether it includes colors. Yes, it includes every pixel information. So colors is included. Yeah. Yes. It's just a binary diff. We do have some internal tools just to make it easy for you to pinpoint what the actual change is. But in order for the framework, it's basically just a binary change. Yes? I can't hear the question. Sure. Yeah, so the question is how would you plug this into Jenkins or CI? So I described two different models. The second model where we do continuous integration and do the bisect, that's what we use at Facebook. But for starters, and in fact, this is the model used by the iOS inside Facebook for now, is that it's the developer's responsibility to record the screenshots the first time he or she commits the code inside. And now in Jenkins, the test should just run and compare the screenshots against the ones that are already stored in the repository. So if that does not match, then the test just fails. So it's a question that. Yeah, but the way we do it at Facebook for the iOS teams is that if your test fails when you change a rendering, you have to rerun the test in record mode, and that regenerates the screenshots, and now you have to send that along with your Git commit. So then your tests are always going to be green. Does that answer that question?
Yeah, I think what you're trying to say is that before committing that code, before committing to Git, you have to run the test that saves screenshots as part of the Git repo.
Yeah. Yeah, but eventually we'll open source something where it'll just be a script which stores the screenshots in MySQL, and then you can probably call that script from Jenkins, and it should tell you if it should send you out emails if something actually changes. That's the eventual plan. Yep, yes?
Does the framework take into consideration of device-specific UI looks that feel like, do I need to generate an massive set of fires and stuff?
Yeah, that's a very important question. So one of the reasons we decided to not do the record verify for Android is that in iOS you have a very specific emulator configuration, so all your developers can use that exact emulator configuration. Whereas in Android, you have to make sure all your developers use the exact same emulator configuration to get a proper screenshot. So here are the things that don't matter. The device size does not matter, because you can generate a screenshot which is much bigger than the view, than the screen size. That does not matter. You can even make it so big that it won't fit in RAM, because we do clever things. But yeah, anyway. So the things that do matter are the device density, because that affects the resources that you pick up, the API level, because that affects the default themes. So yes, it does. The device does affect the rendering. Yes?
So I see the number of gold standard images that we have for testing. If we were to capture that broad combination of technologies, the hit ripple would just blow up the site.
Yes. Yes, so that's why we, that's one of the reasons we like to do the continuous integration and bisect as opposed to record verify. But that being said, the way, for newsfeed, it's nice because we can dump a lot of JSON. But the way I would recommend people to really use this is if you have if you have 10 different views, and each of those views have 2 different configurations, and you're putting them all together, you're going to get this exponential blowout of number of configurations you want to test. So it's just like any other kind of unit testing. I would recommend writing 2 screenshot tests for that one view, like 2 screenshots each for each of these 10 views, as opposed to 2 to the power 10 screenshots for the views that come together. Yeah. Yes?
How do you verify screenshots across devices, right? Because they're different.
Yes, so we actually do not do this yet at Facebook, but it's something on our we plan to do that soon. But yeah, the way we would do this, if we do build it, is that we would use one emulator as our gold standard for actually sending notifications, and we might use another set of emulators, another emulator configuration for potentially just validating that, it might be that you have a resource that is wrong in just one specific density. So you might want to catch that bug. So how does that notification system look like? Because you don't want to send 10 different notifications for each of those 10 configurations. So you have to be a little clever there, which is why we haven't built that out yet, but we think, but it's on our roadmap.
But even detecting this would be difficult, right? Because of different screen sizes, for example, will have different images, and if you do a binary diff, obviously there's a different because
Oh, is that no? So the question. So there, so there it's pretty simple. We use an exact emulator configuration in our continuous integration. So we never change that emulator configuration. We do not test across devices. But if we do want to test it, then we'll have the separate history where, we'll run the same test on a different configuration, but we'll only compare it against the previous screenshot from that configuration. Yeah.
But it's not cross, it's just same.
Yes. Yes.
This isometric tool with something like Spoon, which generates screenshots for all that, and you both tools side by side and look at the test pages and separation.
Yeah, so I have looked at, so I think Monkey Runner provides screenshots and Spoon provides screenshots. as far as my understanding goes, both do screenshots of the activity as opposed to a view, which affects the deterministic thing. But you can still use Spoon screenshots pretty easily for iterative purposes. Like you can generate screenshots and you can quickly see how it looks. But it might be slightly more harder to use the same screenshots to track regressions. And that's one of the goals of this.
I guess what I'm saying is, could we use your tool to take full screen screenshots and then switch out Spoon, and you could show the results for everything?
I guess. So we do support taking full screen screenshots, but I think full screen screenshots is a slightly more, let's say, easier problem because you can just use the Android's rendering frameworks. Yeah, I think I'm sure I'm sure it'll be nice to see how this plugs into Spoon, but yeah, I haven't really given that much thought. Any other questions? All right. Thank you all.